Hey guys, what's up? It's Nate, your Nerdman73 here, and for the first time on the channel, we're going to be getting into computers and general computer science in Minecraft. And a little bit of a disclaimer, if you guys don't know about computing or how complicated the concepts are or what those concepts are, I'm not going to go into depth on this video. I'm just going to explain as much as possible to understand what I will be discussing here. So I will try to find a good video and put it in the description, but I probably will not because most of the videos out there are boring to watch. They're just not very intuitive or hard to understand, and I don't like the quality of those. So I will be looking into making one of those in the future, and once I do, I will probably link it in the description of this video so that anybody watching this in the future can go through and learn about this stuff on their own time instead of digging through the internet like I had to getting started on this stuff. So for those of you who don't know and are sticking around in this video for whatever reason, probably to click off as soon as it starts getting complicated, most computing is done in binary. So a binary system is essentially working with ones and zeros in a base 2 format to compute numbers and then they convert it into a base 10 format for people viewing eyes um, on the screen and such. So that, in my opinion, is easy to understand. You know, it's easy to follow. It's good logic, but it's just so inefficient space-wise, especially in Minecraft, where you're limited to 15 um, pieces of redstone before you have to put a repeater down, and that adds lag, essentially. It adds delay, and that's not good. So what I have done is I've started to lay out the foundations of computing using these bad boys here, comparators. Now, comparators are super useful because they contain, or not contain, but they take the number value of the redstone behind them, and then they put that same number value in front of them instead of indiscriminately just turning them into the number 15 like repeaters do. Now, not a lot of people use these, but they are very, very useful, especially in data storage. Um, so let's get into how uh, this concept works. So this here is the RAM, essentially. It's your long-term storage. I don't remember what the acronym is, but I'm sure that editing me will look it up later and put it into text right about now. So what this does is oh, yeah, I lied. It's called ROM, because RAM is random access memory, which is over here. I'll explain that later. So this ROM is your long-term storage. Now there's 4 different things you can do to this. You can you can input into it um, new data, you know, like a new input, a new save, whatever. You can delete that data. I'm sorry, there's 3 things you can do to it. You can input a new data, you can delete that data, and you can read that data. Now, what this white circuit does and this orange circuit, so the orange circuit is the selector and the white circuit is the deselector. So if I do that real quick, you'll see that these pistons do a special thing and they move their blocks. This is an incomplete circuit, but you'll get the point. Um, because this was buggy the way I did it, you'll notice that this came out and everything. Yeah, in the basic system I put together, I'll have a working version of this. So um, by the time I release the world download for this video in the description, this will be fixed. So you don't have to sit there and figure out how to fix the bugginess yourself. I'll work that out later. I just want to get this video done so that I can release this concept and I can stop talking about it to people that don't care, like my family. Sad me. No, it's not that they don't care. It's just that it doesn't really interest them, so that's fine. Um, but yeah, let me get back on track here. Sorry about the tangent. So what this does is it extends all these pistons, um, which will essentially let the comparators either output or input into the circuit um, indiscriminately without dealing with this mess here. Going to the different outputs at different times, all we have to do is put an output into every single possible data storage, except that this block is missing on most of them, except for the ones that are selected. And then this circuit essentially says, okay, so this has a block in front of it. When the signal is sent through here, it'll be sent through all of these, but the one with the block in front of it will be cleared. And that's basically how that works. Now, moving on, the way it has to be read is kind of weird because here I'll run over here and spoil it for the later in the video. But you see how there's that empty space, right? Now that is essentially a start line. So what this circuit does, this is by far the most complex thing I've built for this demonstration here. So what this does is it takes, so right now it's not activated, judging by the fact that this torch is on. It's not activated, so you notice that when flicking this lever, nothing happens. But when you push this button, right, you see how this line turns off. Now that represents the black, or the empty thing that's going around in the data tower over there. And all that does is it says, okay, there's nothing here. This is the start of the data. You can start reading now, because you don't want to start reading indiscriminately from the middle of the data and then have it be outputted incorrectly. So now you can put an on value of any sort into the circuit, and it'll have no problem to say, okay, go through. But as soon as this turns off, it locks this comparator back out, and no more data can get through. So that is essentially the only caveat to having this sort of setup, is that after you send it into the lines, it needs to be sorted in specific ways, including the ways you input it. So this is the keyboard essentially for an 8-digit system that lists the numbers 1 through 9, and has several sets of short-term data that get filled out sequentially, and then when you activate this purple circuit via this purple line, it sends all the data down the line so that you don't have to press it really fast. That's all it does, is it stars everything up and then releases it all at once into something like this. So this is one of the basic processing units that I've put together. This is a comparison circuit, and what it does is it takes data from either side and it subtracts it from each other, and then if there's anything left over from either one of those functions, it sends that data right down this line. And then this torch is here so that if this torch isn't here, that light's going to be on all the time unless something's wrong in there. And that's not what you want, especially when both sides are going to be deactivated most of the time. You always want something. So this is the first digit of every combination. So you want that torch there to prevent that case from happening. And this circuit is built to handle numbers anywhere of 1 digit to 8 digit, just because of the way that it works. I won't go into details right now. I will include a world download in the description of this video so that you can check it out for yourself. But essentially, it's just perfect timing. That's all. It's timed so that it only inputs when the correct values are at the correct short-term memory slot. So that's the basic idea, and now I will get into a description of that monster over there. Okay, so this is my sort of first build using the basic components that we just went over. This is essentially a combination lock, and the fact that it's this big is ridiculous. Like, honestly, for a combination lock, you could easily go simple, but that's not how I do things. And little side note here, you can tell that this is my redstone because you have some pretty nice looking basic components. You've got the data stack here, which is all nice and neatly organized. It's all stacked very cleanly. You have the keyboard, and the comparison circuit's a little messy looking, but it's still relatively reasonable, and you can see that it's a thing. The redstone spaghetti monster that's happening here, I can't help. There's just so much going on here, connecting everything in a specific way, and the fact that I put everything on this side was kind of dumb, but it's compact. That's all I really care about, is the fact that it's compact and it works. So let me go over how this thing works and how you can manipulate essentially the data in specific ways to get the end result that you want. So this is essentially it's essentially a computer. It's got a RAM for long-term storage. Sorry, that's wrong. A ROM for long-term storage, and then a RAM, which I actually do remember the acronym for, random access memory for short-term storage. This pink circuit here is essentially the CPU. You have your keyboard. So everything, it has all the components of a computer. So this combination lock works essentially like a computer. Now let me explain why this is so big. It uses multiple accounts, so it's a 2-level combination lock. So each account here has a different combination that can be saved and changed at any point in time. So you can put your account in, you can type in the correct code, and then you can delete that code whenever you type in the correct one, and you can type a whole new one all in one operation using the same keyboard, and hence the mess here. And I won't bother explaining what all those wires are. I'll only go over the essential ones, although I may end up hitting on what the different colors mean eventually. So the basics of this are, you have your data stack, which runs down into the reader system, which is barely visible. It is so hard to pick out, but essentially the slime block here, I don't know why that is. I was messing around with this earlier. An earlier take of this went wrong because somehow some of the data got messed up. But I think everything's correct now. Almost. We'll do that in a second. So what was I saying? Oh yeah, so it goes into the reader circuit here, which is barely visible because there's just so much stuff happening here in this one specific spot. Like there's so much, like just wires coming out of everywhere. So it comes to the reader circuit on this yellow line. The yellow line is data that's moving between systems. So the yellow line data comes all the way through here into the right side of the comparison circuit, and then your what you're checking here essentially is your entered combination, which comes, let me go check. It's another yellow circuit that comes around. I'll go over why this is all yellow in a second, even though there's no data actually like going through here. So the data comes around and goes down into the left side of the comparison circuit, and then the pink side is again your CPU. It's your central processing unit. It does all the processing, which is essentially the comparison here of the data, and then it comes out with either a 1 or a 0. It's a 0 until it is a 1 essentially, and it sends a signal into what I like to call the winner's stick, as right here. And then what this does is it triggers the pink circuit, which is essentially the win case, I guess, and this is your output. So when this turns on, your door should open and everything's all handy dandy. Now let's go over how I managed to make the deleting and re-entry circuit a thing. So what this pink circuit does is it pushes a block in front of this red circuit, which makes this able to be used. So right now the winner stick is down. You can see that very clearly. If you press this, nothing will happen. Oh, you can't really see the line lighting up because of the lag, but there we go. So you saw nothing actually happened there, and that's because this block isn't there, and it is not. It's essentially saying you can't delete one of these until you get the correct combination. So that's fun, because essentially what you could do is you could just delete whatever the combination is and then leave and make that account unusable. So this is based on the fact that you have to like go under the whole thing to refill an empty account, which we'll go through in a second. So now instead of randomly being able to delete something, you can delete it after you've inputted the correct code, essentially. And that this isn't unselected until you walk through the door or press this button, um, just so that you have enough time to edit it at your convenience. And then if you walk through this door, it's going to trigger the white line um, and clear everything out. I completely lost what I was going to say. I got off track here. So how this works, right? So we have a RS NOR latch right here, which controls the essentially which circuit the output goes to. The right side here is the comparison circuit, and then once that's correct and the winner stick goes up and the thing is deleted, it switches over to this left side, which essentially sends it straight to the data stack. And the reason why you have to delete it first is if it wasn't deleted before you start inputting a new code, it will completely fill out the circuit, and that dark spot there is completely necessary. As I said before, it shows essentially a little tick mark that says to the reader circuit, okay, start here, start reading from here, and then end reading from there, the start line and the finish line of the data set. So if that little tick mark isn't there, we can't read it, and also, more importantly, the data isn't correct anymore because you've overridden some of it um, by just sort of shoving more data in there, and it overrides all the numbers that are lower than it, and it just messes everything up. So to prevent that, I put this little circuit in here. I think that's everything actually. I think I went over what all the colors mean and all that. So let's demonstrate how this works. So we have the first account selected, right? See all the way down at the bottom there that actually it's easier to see from over here. See how this block isn't there? It's really easy to tell from this side. So because that block isn't there, we have that selected. And since that is not it doesn't have any data in it, the first account is completely empty right now, we can't do anything with it because this data circuit, or the reader circuit essentially, requires some data to be able to read. So if it's all nothing, you can't output anything, and the comparison circuit doesn't know what to do. Because the comparison circuit, if you remember, has a little addition to it that says hold up, if there is no, hold up. It says if there is no first digit here, it's not correct. And that's what we want, which is good. Okay, yeah. So you saw that there was some data here. That's why this is off, but it's incorrect because everything else is 0. So everything on this side is going to be higher than everything on this side, and when they subtract out, it's going to add in some power to there, which is not what we want. So if we hit this cancel entry button, it will deselect the first account and also clear this out. So let's see. And this is my favorite part about this whole circuit. And I've already been rambling for 9.5 minutes. I'm sorry, guys. Or for 9.5 minutes on this half of the video. I may release this in 2 parts. You know what? Never mind. I'm not going to do that. I'll just release a longer video. So let's run through this and show you how to input on an empty circuit in case you have to clear a circuit out. And all you got to do to clear a circuit out is just break one of these, wait for everything to go through, and then put it back in so that you don't have to go through this whole process. So if we select account 1, right, that amount of time between when you put the item in the chest and when it pops out of the floor there, that's the slowest thing in this circuit by far. Like, very slowest thing here, which is awesome. So enough about me bragging about how awesome the circuit is and how lame this little gray one is. That's why it's gray, is because it's lame. This is the button that controls the winner stick. All you have to do is press this button. It'll put the winner stick up. and then you have to come over here, press the delete saved button right here, or delete save. It should be. I'll fix that later. And that technically didn't do anything because the first account doesn't have anything saved on it to delete. But remember that it switches this over to the left side, so you can actually use the circuit. And what we will do, we will save this to be the exact, every single account except for the first one is saved to 1, 2, 3, 4, 5, 6, 7, 8. Now you'll notice something. I didn't have to wait for everything to unclick here because of the way this pulse limiter works. It's really nice. So it's super compact, and what it does is that every time that this changes, it sends a short pulse through this piston and sends a short pulse. It's the shortest pulse that these comparators can take because they can't read a 1-tick pulse. So it has to be slightly longer. Yeah, so that's how that works. So you don't have to wait for the button to unclick unless you're pushing the same thing twice. So there's no bottleneck when you're pressing buttons speed-wise. And then all you have to do, press confirm entry, and it will send your data to the first account, which it appears that it has done. Notice how fast that was. You didn't have to wait a lot of time for data to pass through super long lines like you usually do with most computers because they're so stretched out. You'll notice if you look up anything on YouTube about computer basics or well, actually no, you don't want basics here. You want advanced computers to notice this pattern. But all the lines look like this. They're all completely straight. They take right angles, and they're not they're not this. They're not that at all. They're very well laid out and easy to understand, and that makes them slow because they have to travel over a great distance. And let's face it, people don't want to go through the trouble of making what is it called? There's no delay repeaters or something like that, where it uses pistons, bud powering to essentially get rid of the delay, but still extend the power, which I will be doing a video on at some point. So now that we have something selected for the first circuit, and the first circuit is still selected, but the winner stick is still up, so me typing anything in here will do nothing. So I just walk through here. There's a tripwire here that triggers the white line, clears everything out. It deselects the first account, clears this entire thing out, and what else does it do? Oh, it also runs a signal through the delete circuit on the keyboard, just so that it clears everything. Essentially, you don't want anything backed up in here because as soon as someone starts typing, if there's something here, then it'll just go to the second digit and something will be wrong, which is not very fun. So as you remember, the first account is set to the code 1234567 Let me wait for this to come up. Then we'll go 1, 2, 3, 4, 5, 6, 7, and 8. Perfect. And then we'll hit the confirm entry button. And what this does is it sends a signal through the green circuit, which triggers the or the green wire, which send. Gosh, if I could talk. It sends a signal through the green wire, which signals the reader circuit to send a signal to, or send the data over to the comparison circuit, and then it also sends this data over into the comparison circuit as well. So the winner stick is up, the light is on, and we can pass through. We can delete the data if we want, or if we don't want to go in, we can just hit cancel entry and we can just go about our day. And that is the start of something that's really exciting for me. So once again, this is sort of an original thing. I haven't seen a lot of this used on YouTube, and what I have seen has not been very intuitive or in-depth. They essentially just built a giant box saying that this is a lot of bits using comparators, and that's, kind of lame, I think. So this is basic computing with comparators, or at least the start of it. So once again, I'm sorry for the length of this video, but if you enjoyed it, if you could like or comment, tell me what you think you want to see out of this, or what you think of this concept, or generally just ideas about the channel or anything like that. Feel free to put that in the comments section down below. If you want to look at more videos like this, feel free to subscribe, and I'll see you in another video. But before I let you go, I want to issue a challenge to the Redstoners. If you want to download this world and make this more compact, by all means, please. Also, if you want to try to use these, what am I talking about? These basic circuits in a redstone build, by all means do so. But my challenge is essentially to make this more compact. I don't know if it's possible. I'm sure there's some weirdness you could do with this line here, but essentially to make the basic components more compact and make this mess better. So if you can do that, send me your world download, or just put it in the comments, I'll see it, and show me, because I want to see what I can do with that. That would be really cool to be able to see you get the community respond with their ideas and help me out with this. So once again, sorry for the length of this video. I'll I'll quit rambling and let you go now. I'll see you later.